Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. This video is going to look at adding, subtracting, and multiplying polynomials. Polynomials just means that there are many terms. Just a reminder, a monomial is something like 5xy. It doesn't matter that it has multiple variables, it's one group. A binomial would be like 5x plus 2. Now there are two terms. And a trinomial could be like ab squared plus a squared b plus abc. So in this case, AB squared, that would be like a basket with one apple and 2 bananas. And this basket would be 2 apples and 1 banana. So they're different baskets, and you might have a preference for apples over bananas. Maybe this basket has an apple, a banana, and a carrot. So keep in mind that like terms really means that they have the exact same variables. And that's going to be a big part of what we're looking at today. So you might see a problem written horizontally as 8a to the 4th minus 3a to the 3rd minus 7a squared plus 8a plus 2 minus, we'll do plus, 5a to the 3rd plus 7a squared plus 2a minus 2. And we could line these up vertically, but I'm going to go ahead and I'm going to color code. So in this case, the plus really doesn't have much to do because distributing a positive through isn't going to change anything. So the only term that is quartic, or degree of 4, is this 8a to the 4th. Okay, minus 3a to the 3rd, so that's in purple, minus 7a squared, throwing my pins around, plus 8a plus 2. Then there was the plus sign from the problem. And then we had 5a cubed plus 7a squared plus 2a minus 2. And now we're going to combine like terms. So again, if we think about powers being like how many apples are in a basket, we have 8 baskets. And each of those 8 baskets have 4 apples. There's no other like baskets, if you want to think about it that way. So we're just going to bring that down. Okay. Someone ordered 3 baskets, and each of those baskets have 3 apples. On the shelf, we have 5 baskets, and each of those baskets have 3 apples. So once we fill this order, we're still going to have 2 baskets that each have 3 apples in them. And I'm making up words just to help you visualize. Okay, someone orders 7 baskets that have 2 apples in them. And on the shelf, we happen to have 7 baskets that have 2 apples in them. So once we fill the order, we're no longer going to have baskets with 2 apples in it. So these two cancel each other out. And so they're gone. We don't need any a squared. There's no quadratic term here. Okay? So now we're here we have 8 single apples on one shelf, and we have 2 single apples on another shelf. So when we put all those baskets on the same shelf, we would have a 10 count. And then hopefully you know by now, positive 2 and negative 2 cancel out as well. Let me adjust that problem really quickly. I'm going to make this a 12. Just because I don't want them to cancel out. Okay, so now we have positive 2 minus 12, so we'd have minus 10. Okay, so there are 4 terms left. There is a quartic term, because it's to the 4th power, a cubic term, because it's to the 3rd power, a linear term, because it's to the 1st power, and a constant term. For the purpose of this lesson, do you have to know those vocab words? No, I just like to use them because I think it's good for us all to know vocab words. So this is a polynomial with 4 terms. I don't give it a special name. I stop at trinomial when I do that. Okay, so we combine like terms. All right, new problem. Alrighty, here we go. Oh, I ran off the paper. Okay. So here we have a problem. I'm going to think of these as xylophones and yo-yos. Okay? But I have to be careful because there's this minus right here. And this minus is what's separating the 2 parentheses. Just like before we had a plus separating the 2 parentheses. Okay? So the first thing I'm going to do is I'm going to rewrite this without parentheses by distributing that minus sign through. And I'm also going to color code so that I am looking at like terms. It's not focusing. Come on. Let's see if I can get it. There we go. One more time. Focus. Hey, there we go. Alrighty. So here we have 4 baskets. They have 2 xylophones and 2 yo-yos. Then we have 3 baskets with 1 xylophone and 2 yo-yos. And we're down 7 baskets with 2 xylophones and 1 yo-yo. Okay, now remember this minus is going to have to distribute through. So minus 3, xylophone twice, yo-yo twice, and negative times it. So we did that. And now we're doing that. So a negative times a negative is a positive. And negative times a positive is a negative. Okay, so you might notice the x squared y is in blue. 2 xylophones, 1 yo-yo. And the xy squared is in green. 1 xylophone, 2 yo-yos. They are not like terms because the variables do not match. Once we have this done, this color coding or visually recognizing, we're going to combine like terms. So the pink are going to combine by adding the coefficients, the green will combine by adding the coefficients, and the blue will combine by adding coefficients. And I understand you might say, well, that's subtracting. Subtracting is technically adding a negative, so we are adding like terms. So 4 of these minus 3 of these leaves us with 1. I'm not going to go ahead and write 1 in front. There's an assumed coefficient of 1. 3 and minus 17 leaves us with a balance of negative 14. And negative 7 plus 9 leaves us with a balance of positive 2. So adding and subtracting are very similar. You just need to make sure you pay attention to your signs and that you combine like terms. The other part of this video is going to focus on multiplying. Now, adding had a plus sign in between the two parentheses. Subtracting had a minus sign. When we do multiplying, you generally won't see anything between the parentheses. Okay? So make sure you identify that. One of the most common mistakes I see is students just automatically assume they have to multiply when it's an adding or subtracting problem. So I've seen students take this and they multiply it out, but this is an adding problem. 1x plus 3x is 4x, 7 plus 8 is 15. So make sure that you understand the difference between when you're supposed to add versus when you're actually, or subtract, versus when you actually multiply. Now most of us are familiar with how to do 2x plus 3 multiplied by x minus 5, because you've probably been taught the acronym for FOIL. Okay? If you haven't heard of FOIL, F stands for first. So you take the first part and you multiply it together. So 2x times x. So 2x is the first part of the first one. X is the first part of the second one. You get 2x squared. Then you do outside. That's the furthest to the left and furthest to the right because they're outside. So the 2x would be multiplied by the negative 5, and you get negative 10x. So we did first, and then we did outside. Do you see how that's just basically distributing the 2x to the second parenthesis? Then the inside, that would be the middle. Okay, so that would be the 3 and the x, which would give us 3x. And then last, that would be the last part of each parenthesis. So that would be the 3 in the first parenthesis and the negative 5 in the second parenthesis, which gives us negative 15. So we took the 3 times the x and the 3 times the negative 5. So really, we just distributed the 2x to the second parenthesis. We distributed this and this to the second parenthesis. That's all we did. And then you combine like terms. So we had the 2x squared, negative 10x plus 3x is negative 7x. I've taught a lot of students to instead go back to a grid method. That's a lot like when you guys did mental multiplication. In elementary, you called it the area model. It was just to help you think about your numbers mentally. So 2x plus 3x minus 5. If you've watched my factoring video, you would probably be familiar with this box because we utilize it to go backwards. So 2x times x, 3 times x, negative 5 times 2x, and negative 5 times 3. We're getting the same 4 pieces of information. We've just done it in a grid to help us line up. Okay. Elementary school, you would have done this by, say, you had 23 times 12. And you would have said, okay, 23 is 20 plus 3. 12 is 10 plus 2. And this is actually how I do mental math a lot of times, because I don't have to think about carrying. So 20 times 10 is 200. 3 times 10 is 30. 2 times 20 is 40. 2 times 3 is 6. You add those together and you get 276. So the area model from probably 3rd grade or so is a way to help you think about mental math, and it places emphasis on the tens digit versus the 1 digit. Whereas we can use that same thing here to get the area, because area is length times width, of, or the answer to a multiply problem. So same idea as in elementary school, it's just an organizing. Why do I show you that? Well, kind of the goal of this video is to kind of expand and go bigger. So 6n squared minus 4 times 2n squared plus 3n minus 5. So now, instead of a binomial times a binomial, we have a binomial times a trinomial. So you have two options. You can either distribute this, then distribute that, and then add like terms, or I like to go ahead and use the grid. Since it's a binomial by a trinomial, we're going to need a 2 by 3 grid. 2 terms by 3 terms. Okay. We have a 6n squared minus 4, 2n squared plus 3n minus 5. So we know 6 times 2 is 12. There's 2 n's here and 2 n's here, so when we dump them all into one group, there's 4 n's. 6 times 3 is 18. There's 2 n's from the left, 1 n from above, so when we dump them all together, there's 3 of them. 6 times minus 5 is negative 30, and we only have the 2 n's from the left. Negative 4 times 2n squared is negative 8. Negative 4 times 3 is negative 12. And negative 5 times negative 4 is positive 20. Why did the exponents change? Well, here's why. We're going to do a side note. If I look at x to the 4th times x to the 5th, that gives me 1, 2, 3, 4. 1, 2, 3, 4, 5. So when I look at that total, there I see that x to the 9th. So remember, when you multiply your variables, you add your powers. Okay. Negative 8n squared and negative 30n squared have the same power or the same degree. All the others have different degrees, so the only ones that are getting combined in this particular problem are the ones that I've highlighted in green. So we'll have our 12n to the 4th plus 18n cubed minus 38n squared. So the only way to change your exponent is by multiplying or dividing. When you add like terms, you're changing your coefficient. So be careful, you know the rules on that. And I could go in and explain to you why. Actually, I will. Why does the variables not change when we add or subtract? Okay. Let's look at 8x to the 4th times, or plus 3x to the 4th. What we're doing is we're saying, hey, look, the first one is x to the 4th times 8. And the second one is x to the 4th times 3. So see how I factored out the x to the 4th? And now I'm just left with 8 plus 3. So 8 plus 3 is 11. But most of us don't like to write it that way. We commute the property, 11x to the 4th. So that's the real reason why when we add coefficients, the variable doesn't change, the exponent doesn't change, is because technically you're factoring it out so that you can add your actual numbers. So if you ever wondered, that's why, versus when you're multiplying and you look at it, that's why it changes there. Okay, now, really quickly, I'd like you to think about what is 2 times 5 times 9. Okay. What is 2 times 9 times 5? Did you say the same thing? Probably. Most of us are going to look at this and go, okay, 2 times 5 is 10, and 10 times 9 is 90. Most of us are not going to go 2 times 9 is 18 and then do 18 times 5 because, well, that's still 90. The mental math is nicer on the first one. Some of you might have done 9 times 5 is 45, 45 doubled is 90. That's okay as well. But the point is we multiplied two things together and then we multiplied by a third part. Okay. Here we have a binomial being multiplied by a binomial being multiplied by a binomial. So we need to treat it like that. Here we multiplied the 2 by 5 first, got that answer, and then multiplied it by the 9. So that's what I'm going to do here, is I'm going to multiply these together first. Okay, now that's a binomial times a binomial. Do I care which one goes on the side and which one goes on the top? No, I don't. I don't even care if you actually draw the boxes. I just like having it lined up. Okay, so 2 times 8, xx, y. Negative 3 times 8, an x and a y. 2 times 2 is 4, an x and a y squared. And a negative 6y squared. There are not any like terms. So we're left with 16x squared y minus 24xy plus 4xy squared minus 6y squared. And we still need to multiply it by this x squared y plus 4. Okay, so now we have a binomial being multiplied by something with 4 terms. So I need a 2 by 4 grid. I don't like going tall, so I'm going to go wide. So we have that 16x squared y minus 24xy plus 4xy squared minus 6y squared. Told you I was going to go wide. And that is being multiplied by that x squared y plus 4. Okay. So let's do the top row. I'm not going to worry about the plus 4 row right now. So we'd have 16, 4 x's and 2 y's, minus 24, 3 x's and 2 y's, plus 4, looks like 3 x's and 3 y's, and a minus 6, 2 x's and 3 y's. Okay, now I'm going to multiply the 4. 4 times 16, that would be 40 plus 24, so that's 64. I did that, in case you were wondering, I did 4 times 10 plus 6, that's how I got the 40 plus 24. So, again, I use this for mental math. We would have x squared y, I know some of you are like, I'll just grab my calculator. Negative 96 xy plus 16, because 4 times 4 is 16, xy squared, and minus 24y squared. Okay, we have 8 terms. Are any of them alike? Let's see, this is the only one with an x to the 4th. These 3 are, no, just these 2 have x cubed, but their y's are different. These 2 have x squared, but their y's are different. These both have a plain x, but their y's are different. And, okay, we have no like terms. So what's our answer? It's a polynomial with 8 terms. That's what it is. There's that squared. So why do I use a grid? It's just to keep things kind of lined up so that we can actually see our multiplying pretty quickly without making any mistakes because we forgot a term. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.